Okie dokie. Let's look at number 26. So we have a big, beautiful circuit that looks like so. Swoop, boop. Resistor, swoop. Resistor, swoop, boop. Resistor, 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 battery. Whoop. Plus, minus, plus, minus, plus, minus. This is 1 ohm. This is 6 ohms. This is 20 volts. This is 4 ohms. This is 1 ohm. This is E1. This is 1 ohm. This is E2. 2 ohms. Alright, this is point A. This is point B. So problem 26, find the EMFs E1 and E2 in the circuit and find the potential difference of point B relative to point A. So now they also tell us that we have a 1 amp current going that way and a 2 amp current going that way. Okay. So, first things first, draw our currents. So because they told us that down this branch we have 1 amp, that means everything along this branch is 1 amp. And that means everything along this branch is 2 amps. So we have 1 amp here, 2 amps here. Okay? So from our junction rule, we can look at either point A or point B. So we see that we have 2 amps coming in here, 1 amp going out. So in order for our junction rule to hold, 2 amps going in means I better have 2 amps coming out. So that means the current in this branch has to be going this way, and it has to be 1 amp. So I have 1 amp from my orange plus 1 amp from my red equals 2 amps from my pink. Alright, so now we can start doing our loops. So loop number 1, let's go around here. Okay. Now, since my current is going this way, I like following the current. That's a personal preference. So my loop is going to go this way. So I'm going to start here at A, going to go backwards through the orange current, but then I'm going to go with the red current. Okay? So blue loop. So I start at point A. I'm going through this resistor, but I'm going against the current. So that's plus IR. So 1 amp times 4 ohms. Then I'm going against the current through here, so that's plus IR. Then I'm going down in voltage across E1, so minus E1. Now I go up here. Now I'm going with the current, so it's minus I, which is 1 amp, times R. Going from minus to plus through my battery, so I'm gaining 20 volts. And then with the current, so minus IR, which is 1 amp times R of 1 ohm. and that's a closed loop. I went all the way around in a circle, so that has to be equal to 0. All right, so if I simplify this down, I've got 4 volts plus 1 times 1 is 1 volt minus E1 minus 6 volts plus 20 volts minus 1 volt equals 0. So my 1's cancel. So I have 4 minus 6, so minus 2, plus 20 is plus 18. So I have minus E1 plus 18 volts equals 0. So E1 is equal to 18 volts. All right, next loop. Okay, so now let's do green loop around here. I'm going to go this way because it goes with the current for everybody. Okay. Alright, so I'm going to start here, and I'm going to go this way. So I'm going with the current, so that's minus I, which is now 2 amps through there, times R, plus to minus, so I'm losing E2 with the current, so minus I R, back up and around. Now I'm going minus to plus, so plus E1, but E1 we just found was 18 volts. So I'm going to plug that in instead. Then I'm going with the current, so minus IR, but my I here is 1 amp, so I'm on orange land now, minus IR. And I went all the way around, so that's equal to 0. So I have minus 2 volts, minus E2, minus 4 volts, plus 18 volts, minus 1 volt, minus 4 volts equals 0. So I have minus 2, minus 4, so it's minus 6, plus 18 is positive 12, minus 1 is 11, minus 4 is 7. So minus E2 plus 7 volts equals 0. So E2 equals 7 volts. Okay, so now to get the voltage from A to B, we can follow the same Kirchhoff rules that we do, except we're not making a complete loop, so it's not going to be equal to 0. So the voltage from A to B, I'm actually going to start over here at B and go with the current. So going with, I have minus to plus, so I'm gaining gaining E1, which is 18 volts. Then I'm losing minus IR, losing IR. So I have 18 volts minus 1 volt minus 4 volts. So 18 minus 5 volts is 13. So the voltage difference from A to B is 13 volts. The end.